Hello there, welcome once again to Maths with Ish, brought to you by 1 Million Teachers. Now, I gave this particular question last time, and today we'll be looking at the solution to it, okay? So it says an unbiased coin is tossed twice. What's the probability of getting at least one tail, a head and a tail, at most one tail? Now, let me explain something here for you. Now, whenever they say a coin is tossed twice, it's actually treated the same way as when two coins are tossed once. Okay, so if I have a coin and I toss it twice, it will give me the same probability as when I take two coins and toss those two coins once. Okay, and whenever you have a question like this, the best way you can solve it is the outcome table. But you can as well use the independent invent formula to solve the particular problem. So now I want to show us how we can use the outcome table to solve this particular problem. So now I've also discovered that most of us don't know how to construct the outcome table. It's very easy. Now, solution, this is how to get your outcome table. You know that a coin always have two sides. So the first thing to do is to draw something like this. You have the horizontal bar and then you have the vertical bar. Now we can separate here to represent the first faces of the coin. So if the coin is tossed once, there's a probability of getting a head or a tail. Now, if the coin is tossed the second time, let's call that C2. There's also a probability of getting a head and a tail. So let me put that head and the tail here. So you can see on this horizontal column or horizontal row, we have the head and the tail representing when that coin is tossed for the first time. Then on this vertical column, we are having a head and a tail representing the two options when that same coin is tossed the second time. Okay, so this is what we can now use to get all the possible outcome in our outcome table. So now let's fill it up. So let's go. If this head interact with this head, I'll be having H. If this head interacts with this T, I'll be having HT. If this T interacts with this H, I'll be having TH. And if this T interacts with this T, I'll be having TT. So we have gotten the total possible outcome. Now let's count them. How many total possible outcomes do we have here? If we count, we have 1, 2, 3, 4. And this is our sample space. So anything we are solving here is going to be what? Over 4. Remember that our formula for probability is what? Is the number of events divided by what? The total number of possible outcomes. So that is what we're going to do now. So now we have gotten our outcome table. Everything becomes so easy now for us to solve. Now let's answer the first question. You see, find the probability of getting at least one tail. At least one tail simply means what? That the least you should have is one tail, which means that you can have more than one, but that the least don't go beyond one tail. So if you look at this, we have one tail here. So this is an option. We also have one tail here, and then we can also accept these two tails because they said at least one tail, which means don't go beyond or below one tail. The least you should have is one tail. So which means for this question 1, we need this, and this. And how many are they? Let's count. 1, 2, 3. So for question I, the probability of one tail of at least one tail is going to be what? 3 over 4. Remember that it's probability of the number of required events divided by the total number of possible outcomes, and that is 1, 2, 3, 4. That's this 4, and then we have 1, 2, 3. Do we get that now? Now let's answer the next question. The next question says a head and a tail. This one is quite straightforward for us to get. Where can we see a head and a tail in this outcome? So a head and a tail, that is going to be this. Let me use a green marker this time. We have a head and a tail here. We also have a head and a tail here. So our answer to question number 2 is 2 over 4, because we have a head and a tail, a head and a tail. Okay, now let's go to the last question, which is our question 3. Our question 3 says at most one tail. This is almost similar to the first one. At most one tail simply means what? That the highest they need is one tail. At most one tail. So which means that you can have a situation whereby you don't need a tail. So there, what we need is, we have one tail here. So I'm going to take this. We have one tail here. I'm not going to take this because we are having 2 tails. What they say is most. Most simply means that the highest they need is one tail. But it is possible for us to choose this. Here, there is no tail at all. So we are choosing HT, TH, and HH. So let's count them. 1, 2, 3. So our answer, our probability to that is 3 over 4. Can you see that? Okay, let me write it here. So for our question 3, the probability of at most one tail, let me use T for tail. So the probability of at most one tail is going to give us what? 3 over 4, based on my explanation. So I hope we have gotten something from this today. Please remember to like, to share, and to subscribe to this channel. Thanks for watching. Have a great day.